All right, folks, it's Bass Action, back in action here. In this video, we are going to review a few more geometry ideas. We're going to look at arc length, sectors, and segments of circles, okay? In our first pre-calculus lesson, the first real pre-calculus lesson, we are going to take these two formulas for arc length and sectors, and we are going to convert those to a new form that can be used in our pre-calculus classes with a different way to measure angles. So it's important to understand the geometry perspective before we move forward. Also, due to some technical difficulties, please make sure that your piece of paper has the little arc symbol over this HG and this HUG. That's going to be important for us. All right, now let's look at our formulas. Arc length, okay, the length of an arc written in words here, the length of an arc is, that's going to mean equals, okay, so length of an arc is, here's our equals, equal to the portion of the circumference. Now, when we're talking about this portion of the circumference, that is telling us that it's going to be however many degrees of the circle that arc is taking up out of the full circle. So that's our portion of, meaning multiplication, the circumference of the circle. So this is our definition formula, but many of you probably would remember from your geometry days that this can easily be rearranged into a nice proportion. If I take the circumference of the circle and I divide both sides by the circumference, I get this nice proportion right here. Arc length out of the circumference equals arc measure out of 360. Okay, so we're going to use that to look at a couple examples real quick to refresh our memory how to find arc length. So if I want to find the exact, remember that important word, no decimals or anywhere in our worker answers, the length of HG, that means I want to know how long is this part of the circle. If I were a little bug and I were crawling along the circle, how far would I have to crawl? Okay, so what we're going to do is we're going to use this proportion. If you would like to use the definition, you're welcome to use that one as well. I just know lots of students like the proportion. So that arc represents 50 degrees out of the full 360 degrees in the circle. I don't know how long that little piece is, but I do know that since the radius of the circle is 9, the length of the entire circle is 18 pi. Remember, circumference of a circle is 2 pi r. That's going to be our most useful form to use. Then I'm going to do some quick cross multiplying and a little reducing. So I'm going to get rid of those zeros. I'm going to cross multiply here. I'm going to get a 36x equals a 5 times an 18 pi. Then I want to show you guys a little trick here. Notice I didn't multiply this out. Let's pretend we don't have a calculator, which of course lots of times in pre-calc we don't. If I divide both sides by the 36 now, it's really easy to cancel this without needing a calculator. So the length of my arc turns out to be 5 pi over 2. I don't know the units, so I'm just going to call it a u. Okay. Now, if I wanted to do the other side, let's say the question had asked how long HUG is, okay? So let's pretend that had been the question. Then we would look at this and we'd say, hey, that portion of the circle is 310 degrees. So now we're going to use we would use 310 out of 360. We wouldn't know how long it is, but we would know the length of the full circle of 18 pi. So again, we can do that nice little canceling. We can do the nice cross multiplying. 36x, again, don't multiply it out because why bother? Divide both sides by 36. These would cancel. The 18 would go into itself once, 36 twice. And notice that even if we had been given the other side, this still would have been very easy to do without a calculator. 31 pi over 2 units. Okay? Now, let's take a look at area of sectors. It's really not much different than arc length, except it's going to actually fill the space on the inside. Its definition, the area of a sector, is, that means equals, equal to the portion, okay, that's arc measure out of 360 again, of means multiplication, area of the circle. Remember, the formula for the area of a circle is pi r squared, okay? So, just like before, I can take this definition and rearrange it into a proportion by dividing both sides by this area of a circle. So then I get sector out of area, and notice the right-hand side of the equation is still the same. So if I want to find the exact area of this sector, that means it wants to find this shaded region. Now, if it's not super clear on yours, just because of how it may be copied, this sector on this problem is this piece of the pie, okay? Or the pizza, or whatever food you want to think of, circular food. So if I wanted to find this area, the area for the, the arc measure for this area is going to be this 150 out of our 360. We don't know the area of that space, but if the radius of the circle is 12, the area of the full circle is 144 pi. So now, again, I can do a little reducing. The zeros are going to cancel. 3 is going to go into 15 5 times. It's going to go into 36 12 times. Now I'm going to cross multiply 12x. I'm going to do the same thing I did before. I am not going to multiply this out. I'm pretending I don't have a calculator. Then I can divide both sides by 12. Cancel, cancel. 12 goes into itself once, goes into 144 12 times. So the area of this sector is going to be a nice 60 pi, okay? And area is always labeled unit squared, okay? So there's a quick little area problem. Last one we're going to look at is a segment of a circle. Now, this is a specific definition. A segment of a circle is going to be an area bounded by the circle, 2 radii, here and here, and a chord that connects them. So the area, or the segment in this case, is this little piece, this funny little piece right here, okay? So segments are a very specific geometry shape, and we're going to find those by doing the sector minus the triangle. Now, if you don't quite see it, the sector is going to be this piece of the pizza, and then the triangle we're going to subtract is going to be this triangle right here, okay? This is going to allow us to review some of our earlier stuff. So our sector in this case is going to be, now this one I'm going to write this one out a little differently. I'm going to use this one as the definition so you can see it the other way. The portion of the circle, 106 out of 360, times the area of the circle. The radius is 5, so I'm going to fill in a nice 25 pi here. Okay, now when I go through and I reduce all this, I could reduce this down to a 53 and a nice 180. I can keep reducing and keep reducing, and I will eventually get my area down to, for my sector, it's going to be kind of ugly looking here, 265 pi over 36. Now, the triangle is what I really wanted to draw your attention to here, because this triangle takes us back to the Pythagorean theorem work we were doing earlier. This triangle right here, we're going to draw it out separately. All the radii in a circle are the same, so I've got a 5 and a 5, and this side of the triangle is an 8. So notice we're back to that nice isosceles triangle. We're going to draw in the height. We're going to label this little piece as 4 and 4. We can see that this little right triangle over here on the right is going to make a nice Pythagorean triple. So the height of that triangle is going to be a 3. So the area of this triangle is going to be 1/2 the 8 of the base and the 3 of the height. So the area of this triangle is going to be an 8 times, or a 4 times a 3, or a 12. Okay, so now that I have this area of a 12, it is always a nice practice to go ahead and put that entire expression into a single fraction. So it's nice to get that nice common denominator. Sometimes students get a little confused where these numbers come from on my answer keys. We're going to write this as a single expression. So our final answer is actually going to be written as 265 pi minus 432 all over 36. So we have one nice single fraction expression, and this is going to be centimeters squared. Okay, so that is going to be an important idea later. We will come back to areas of segments.